Hello, hello. Are we live? Okay, welcome back to the Advent of Sintran 2024. Today is day 10. So, let's edit that. It's going to be empty because I haven't downloaded anything yet. Let's run my downloader. Finally, a 2-digit day. Okay, I should have input. Haven't seen anything about today. Or I did hear somebody say that it's a matrix, so apparently I have a 40 by 40 matrix. I don't know if it's a grid problem or like literal matrices. Let's find out. So this is our example input. Height. Okay, another height map. There was a problem like this maybe 2 years ago with a table of heights. Let's save the test input. Four lines, 4 by 4. Okay, I think I got everything there. Just tried a tmux key binding in Firefox, so that didn't work. Alright, so what are we doing with heights? I'm going to find, a trail that is as long as possible. Starts at 0, ends at 9. Increases by 1. No diagonals. That's kind of like the usual Advent code rules, except for that word search a few days ago with the Xmas word search. Can there be more than, there's probably more than 1 0. There are a bunch of zeros in here. So we have multiple trailheads, right? What are we doing? Are we making it as long as possible, or are we doing a score? What are we optimizing for? Oh yeah, you can't go up. What? Okay. Okay, so it can reach that, and there's only 1 9. This trailhead has a score of 2, so it can fork. Why can it fork? Oh, because it's a valid trail. You just have to find valid paths. Okay, so we can't get to that 9. I don't know why they put it in the diagram then. So you can go this way. You can only go up, down, left, or right, and only increase the number by 1. But it doesn't matter that we can reach this 9 multiple ways. The score is just 4. 1, 2, 3, 4. So we can get to this 9 via multiple paths because they have like this whole 4 by 3 rectangle filled in. But that 9 still just counts once. So we're doing a search. I think you could do a depth first search or breadth first search. I don't think it matters which one you pick. 2 trailheads. There's a 0 there. Why don't I just make my life easy? Okay, 2 zeros. And then where can we get? We can get there, right? And then we can get there. But then starting from this 0. Oh, can you not? You can't go down? You can only go up by 1? Can you go up? Can you go 0? Increases by a height of exactly 1 in each step. So you can't stay level. You always have to go up. Okay. So which one is the actual example? I think maybe this is the better example to work with. Five, 6, 5, 3. Okay. Doesn't sound too bad. Plus mid. I used the larger one. Oh, yeah. The larger example. So actually, I already saved one that I don't care about. So what is this? 8 by 8? Yeah, 8 by 8. Oh, welcome to the stream, plus mid. How is Advent of Code going for you this year? Have you done this in previous years? Okay, so I want to look for all the trailheads and then do a search starting in each trailhead. Either depth first search or breadth first search. I'm gonna do whichever one is easier. So is there one with a stack and one with a queue? I think that's basically the difference between the two searches. So I think they should be equally easy. Will I have to Google it, or can I just remember how to do a search without looking it up? Maybe. Okay, so I should be able to read the input file and just echo it back line by line. That's what my template does. Do you think this is harder, like as a whole, all 10 days? Do you think this is harder or easier than previous years? Easier? Yeah, I think so. I've gotten all the stars so far. Last year, I only got the first part of day 5. So that's, I don't know if the sample size is big enough, but yeah, to me, I think this year seems slightly easier. We're only on day 10, so it's going to get a lot worse. Probably. Okay, let's count the size of the grid. So count the lines in the file, and then count the length of the first line of the file. And then I don't need a while loop. H for heights. Why not be verbose? Those are going to be my heights, and we're going to load those from the file. Got both stars in 5. Yeah. I looked it up. Oh yeah, that was like the maps, because I've looked at this a few times in the past few days. I keep thinking, Like 5 was hard. Wait a minute, what was day 5? I have to go look it up. So I've looked it up multiple times in the past few days. XY is string. Let's get it to an integer. So parse I32 string X. I think that should work if I haven't messed anything up. Okay, there are my heights as a matrix of integers. Looks correct. All right, now I need to know how many trailheads there are. That should be easy. It's the number of heights that equals 0. That's just a built-in function. So there are 9. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9 trailheads. I didn't have to count. It was right there. Doing the tasks in Go. You have no idea about Fortran? That's okay because this isn't actually Fortran. This is Syntran. It's my interpreted language where the interpreter is written in Fortran. So it has some relation to Fortran, but superficially this looks more like Rust than anything else, probably. I did this last year, too. I did as much of Advent of Code as I could in Syntran. And the year before that, in 2022, I did it in Fortran. I never get 50 stars. I get like 40, low 40s number of stars. Okay, so that's the number of trailheads. And I think I want to scan through this once and just save. No. I don't think I need to save the trailheads. I can just process them all on the fly. The challenge is to write a language that can solve the challenges. Yeah. The main driver of the Syntran language here is Advent of Code. So I'm practicing like Advent of Code driven development. Yeah, and I don't think I need to save this stuff. I think I want to go in reading order. That's the way that they listed the scores, in reading order. So I'm going to loop the same way. There's just a double loop. I only need one set of brackets because this for loop just contains another loop. And then I'm going to want the score. Might not even need this. I could probably just add to the sum every time I find a 9. So I think I need a queue or a stack. I don't think it matters whether you do depth first or breadth first. So in a queue, you only need the end. No, a stack you only need the end. Yeah, so I'm going to do a stack because you only need one. You only need to keep track of one end. In a queue, you need to keep track of the front and the back, so it's just slightly more complicated. Stack, yeah, that's what I said. So I'm going to over allocate to like the biggest possible size. I don't know if I should initialize to 0 or -1. Let's do that just to be safe, because that's out of bounds. I'll know if I pull out like an invalid value from my stack. And it's going to be 2-dimensional. I want to keep track of positions in the 2D grid, so it's going to be 2 by, in the worst possible case, nx times ny. And then I want to keep track of the end of the stack. Doesn't matter, just abused go slice as a queue. Oh, yeah. I don't have like a literal queue type, I'm just using an array here, because I don't really have very advanced types either. I have arrays and I have structs, which I just added recently. I don't think I've used structs for any of Advent of Code problems yet. That's going to be the... about SPTR? I don't know. Naming things is hard. And then I want to push something onto the stack to start. No, I'm going to do that inside here. So yeah, maybe I want to allocate all of this stuff inside. I don't think I have to reallocate. I think I can just reset the stack pointer. And maybe I should like reinitialize to -1s to be safe, but I'm going to risk it. Because like for performance, you probably don't want to free and reallocate this on every one of these loop iterations. It's only 40 by 40. It's really not that big of a grid for the real input. All right, yeah, have fun. Have a good night. So I want to push something on. First of all, I want to wait until I find a 0. Height is 0. That doesn't need to be nested either. Okay, then we're going to start a search from this location, XY. Trailheads are at 0. Okay, so we're going to start a search. We're going to push the current location onto the stack. So, stack both X and Y at S pointer is going to be X, Y, and then S pointer gets incremented. So that's how you push. I think, so I don't have plus plus in this language. I think you could do something crazy, like use a parentheses to have that as an expression, but then you add 1 to it, so you have to make up for it by subtracting 1, and then you don't have to do this as a separate statement, but it's kind of a mess to look at. So maybe it's better to do this as 2 statements. Yeah, that's how you push. And then we're going to iterate until we get to the end, until we empty our stack. So we're pushing the trailhead, and then we're going to push 4 neighbors of the trailhead if the heights are increasing by 1. Right? We can't stay level, right? I think that's the criteria. Sorry about the volume. Hiking trail is any path that starts at 0, ends at 9, and always increases by a height of exactly 1. Okay. So you can't stay level, you can't go down, not even by 1. You always have to go up. It's kind of a bad hiking trail, because then how do you get back home? Like, what kind of hike is that? You just stay at the destination forever and then you die there? It's a little macabre. Do I want to write this code 4 times? I could like encode directions like I have done in previous days, but let's try doing it the wet way, see how bad it is. It's going to be pretty wet because then it's just one line to check if the heights are reachable. If height, it's heights, right? Yeah. X plus 1, y. Let's have a helper. Heights, x, y, the current height. How about the current height plus 1? Because that's what I actually want to compare to. I'm not going to be wet in my pushing, or I'm not going to be dry in my pushing, but I'll dry up h plus 1. So then we're going to push this neighbor. X plus 1, y. And then repeat this for the other. There needs to be a bounds check. Yeah, you know what? I'm doing this the dry way. So let's just make these global variables. You could make them local. It really doesn't matter. This is the same code that I've written many times. So -1, 0, 1, 0. It shouldn't matter what order you put these in. A couple days ago, we had like guards going on paths with loops in the paths, and for that, the guard always turned right. So it was helpful if you listed your directions in clockwise order. Today, we're not doing anything like that, so it doesn't matter what order you list these in. Yeah, and this is 2 by enders, right? Okay. So I think there's no point making a variable now there. Forget about that approach. So for ID in iterate over the directions, if let's get the location of this. It's going to be the location of the neighbor. So x of the neighbor is x plus ders 0 ID, and similar for y. That 0 becomes a 1. And then figure out if the height is reachable. Bounds check, that was the whole point of this, because I don't want to copy and paste the bounds check 4 times. I think I want a helper function for this, but maybe let's finish the challenge first. So if that and that, and for y, and that, we're in bounds. How about that? Then I won't have to nest the next thing. Now we're gonna push it. So stack similar to what I wrote here, except instead of having a hard-coded x plus 1, it's going to be xn. xn, yn, stack pointer gets incremented. I want to pop. So all of my x's are wrong. Do we want to decrement first? Yeah, I think we want to decrement first. So when you push, you set the values and then you increment. When you pop, you decrement and then you grab the values. Stack 0. That's a 1. Okay, so that's popping the search location. And then I want to replace some of this stuff. X, Y, only the single characters. This should probably be a function that I don't have to worry so much about what my variables are named. I can have arguments versus parameters that have different names. So this is actually SX, SY, and this is commented out. I'm just going to delete it. Okay, so we pop this location. And then we push the neighbors that are reachable. This pushes, this checks if they're in bounds. Where's the height condition? Yeah, so that should be here. If heights xn, yn is not heights xs, ys. I'm putting a thing after x and y. So I'm making a lot of extra work for myself. SX, XS, SY, YS. Okay. These are bad variable names anyway. It doesn't matter. Okay, so we get the neighbor location. We check if it's in bounds. We check if it has the correct reachable height that increases by 1. That's the rule. I think that's it. And then we have to update the score. We also need a visited array, because if we get to the same 9 multiple times, we only want to count it once. And this can also optimize the search, because we don't need to revisit the same point multiple times. I'm gonna set it up here, and then I'm gonna have to reset it at each iteration. NX, NY. And then this is going to reset to false at every iteration. When do we say it's visited? And when do we guard against revisiting? I think I can do it right here. If visited is this gonna work? really worried that this is in the wrong place. And then if we haven't visited it yet, now we have to set it. Maybe I should do that somewhere else, like inside this loop. I don't know. I think there are multiple ways that you can do this. And then I need the score. So, scores +1. And then can I print the scores down here? See if that runs. It probably won't. And then I'll need to add up the sum too. Why not do it? Holy shit, that ran. And it got the right answer. Did I get them in the right order? 5, 6, 5, 3. I think I did. 5, 6, 5, 3. 1, 3, 5, 3, 5. 1, 3, 5, 3. Yeah. Right scores in the right order. That's a lot of correctness. Let me run it on the real input. I don't think there's too much logging here. It's just the grid and then the scores. There aren't going to be that many scores. Worst case scenario, 1,600 scores. But less than that because not everything in the grid is a 0. Let's see. I've got a good feeling about this. Okay, that's part 1. Streaming for 32 minutes. Not great, not terrible. I talked a lot. Do we have to get to a 9? Yeah, I think we always have to get to a 9. So, what did I just do? Did I just do breadth first or depth first? I think I might have to do the other one. Well, I think I have to do depth first to be able to count the number of distinct trails. And then you might want to visit things multiple times. So like you're going to get to this 8 3 times, no matter which trail. But by the time you've traversed all 3 trails, you're going to get to the 8 3 times. Same with this one. So I used a stack. A stack is last in, first out. So isn't that depth first? Usually a stack. Q. Non-similar. Okay, yeah, so depth first uses a stack. Breadth first uses a queue. So you could do part 1 using either depth first or breadth search. For part 2, I think you want to go depth first. And that's good because that's what I just implemented. But I want to take out... Am I going to get infinite loops? I think because the heights have to increase, this is like a directed graph. So if you had a non-directed graph where you could go in both directions, then you really need this visited or discovered condition. Otherwise, you're going to get infinite loops. But because we have a directed graph where you can only go up, you can only gain elevation in the hike, we can get rid of this condition and we won't get infinite loops because reachability depends on height. So I think we're good. I was worried I would have to change from a stack to a queue, but I don't have to do that. Yeah, let's go back to the test input, and then is it still the same example? I think this is doable. Is there more plot at the end here? This is just plot? Usually like all the plots at the beginning, and then I just skipped that, but now we have plot at the end. That's weird. Wasn't expecting it. Okay, so let's see if we can get these ratings. I should be on the test input. Okay, let me copy part 1 and start mutating that into part 2. And uncomment the call to part 2. So now this should just run part 1 twice. 36. 36. Okay, we just ran that twice. All right. Is it just taking out the visited criteria? Rating. Okay, so they don't all have to end at the same location. They just have to start at the same location. I was confused about this example because they start and end at the same location. But we have trailheads. What did we have, like 6 of them? 9 of them? 1, 2. There were 9 in the first example. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's still 9. I was worried that it depends on like start point, end point pairs, but a trailhead is still just the start point. So we want to know how many 9s we can reach, and if we can reach a 9 multiple ways, that increments the rating. So am I in part 2? I don't want to accidentally edit part 1. Yep. So where's score? I'm not even going to put a comment in to describe this because I don't know how to describe it other than the puzzle. Rating, 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 rating. Okay. Now, is it just comment out the visited condition? 20, 24, 10. Oh my god, it's that easy. I'm lucky I did depth first instead of breadth first, because if I did breadth first for part 1, then I don't, does it matter? I don't think it matters. I think you can do either search for both parts. Is the sum 81 for this example? All right. This is like the easiest part 2 yet. If I'm right. You know, I could still be wrong on the real input. I've got a good feeling though. Not bad. 30, 40 minutes. You know, it's 7 p.m. Eastern time, so really it's more like 19 hours since this puzzle was released, but I didn't look at this before the stream. Okay. Not a bad day. Oh, yeah, I had a to-do. I've been thinking about this for a while because I think I thought of this independently. I have to write these conditions all the time. If 0 is less than a location and that location is less than some upper limit, and I also have to do this frequently for x and y. So I think I want like an inbound function or an inbounds plural function. I don't know which one I want. So do I want to write, I have to write the function, but I want to write my call to the function first. So I could write not in bounds plural, and then like the lower range is 0, 0, x and y. The upper, or the current location is xn, yn, and then the upper limit is nx, ny. So do I want to write that, or which way looks better? The other thing I have in mind is inbound singular, and this is going to take all scalars. So just x, 0, xn, nx. But then it's not enough to just check x, so then I also want inbound and inbound 0, yn, ny. Need one more parenthesis. It's fewer characters this way. Is it just because this word is repeated? Yeah, if I don't repeat the name of the function, it's the same number of characters. You can see that these things line up very nicely, even with the parentheses. So basically the parentheses, you trade brackets for parentheses. I guess I like this one. Sometimes you might want to check this on scalars. You might want to check if a scalar x is within a range 0 to n. But you can just make scalars into an array of length 1. So if I ever wanted to do that, I could still write something like this. Then you have brackets that you don't really need, but I think it's worth it to have a more general function than something that's scalar only, and then you have to do the and you have to remember De Morgan's laws. I think I want something like this. So I thought of this, I think I thought of this independently, and then I saw somebody else's code that had like a similar helper function. So I think I want to make this and then put it in my utils eventually. So let's make a helper function. Function inbounds plural. So we're going to have a lower limit. That's a vector of integers. The other thing is, like, I might have to copy this for I32 and I64, but I can just copy and paste it when I need it for that type. So we have a lower bound, some variable x, and then some upper bound or high bound. And these are all vectors of integers. This returns a bool. Yeah, so if we check all of them and everything's okay, it will return true. Or we have to loop through everything, because it's a vector that we're checking. Everything is a vector. Could have written a scalar version, but this actually allows us to optimize and do short circuit logic. I don't really know if Syntran does short circuit logic. If you wrote like a Boolean with a bunch of ands, because I think it kind of depends. Does it depend how Fortran does it? No, I think I just evaluate everything all the time. Yeah, I don't think I have short circuit logic. So this could be more optimal if I have a loop, and then I can break out of the loop early if I find something that's out of bounds. Size x, okay. 0, they're vectors. And then we can just check things one at a time. So if x I less than low I, return false, we can just return immediately. And then we have to check the other bound. But this is going to be greater than or equals, because the upper bound is going to be exclusive and the lower bound is inclusive. That's usually how I do my ranges. I think that's it. I think that's it. Did I write this function correctly? So we're going to see the part 2 answer. That just changed 1030. What did I submit? So I didn't change part 2 actually. 1034. Let's get rid of most of the logging. So that will just print the answers, or the final answers. 459. Is that what I submitted? Okay. There's always a chance that I have a memory bug and something is wrong, but it's not crashing. It's giving me the right answer, so I guess this works. Inclusive, exclusive of high. It's just the natural way to do ranges. And then this is part 2. Just pasted in the same function call from part 1. 1034. Still 1034. All right, now I have a helper function, and I don't want to just define it here. I want to move it into my utils library. And then I can reuse this on other days, because I do have to write these conditions a lot. Basically, every grid problem. I know I've had to do it at least once this year before today. Probably more than once. I can't even remember. It's almost every grid problem. So let's get it out of there. Let's edit utils and just put it at the bottom, I guess. I don't know where else to put it. And then does this still run? I think, did I have a comment about that another day? Git grep. Day 4? I feel like it was more recent than that. Like, look at that. That's basically the same condition. We're checking if it's out of bounds. So you can check if it's out of bounds by checking if it's not in bounds. So it's not like you need multiple functions for out of bounds versus in bounds. And this, yeah, this must have been the word search problem. Xmas. I thought I had like a little to-do note for myself. But I have a lot of to-do notes for myself. There it is. 2 days ago, day 8. Oh, I grepped for bounds, but this is just bound. All right, this is the only thing I have open, so there's no tab completion. Look, it's basically the same thing. And this actually has a vector. It's anti-0 and anti-1. This was the antenna day with anti-nodes. So this is the anti-node location. So the lower bound is usually 0, but sometimes you might want to check some other lower bound. So that's an argument. And then the upper bound is usually like the number of columns and rows, nx and ny. Yeah, so that would have been useful on day 8, and it's useful today on day 10. It's probably going to be useful many more times in the future. So now it's finally a function. All right, I think I'm ready to commit and probably wrap up the stream. Maybe find somebody to raid. What's in here? Okay, so this is in utils now, so it shows up in the diff. And we added that comment to day 8. Maybe I should talk about what I did with day 9. So yesterday on day 9, I wrote some really terrible code. Not that one. Just main.syntran. Part 2. Now I have part 2 old. And then I have something new here. I have part 2. So instead of calling them, I'm not calling part 2 old. But part 2 old is what I wrote on the stream. And this is a mess. It starts out okay. But then, yeah, there's a big comment here about how much of a mess this is. And here's where the mess starts. We have while loops. We don't have break statements, but we have Boolean variables that control whether I'm going to break out of a loop or not. And there's a break outer and a break inner for one of the nested while loops. There are no breaks here, but there are lots of other nested while loops. So this is scanning through blocks of the disk. This is the wrong approach. This is like the approach that worked for part 1, when you treat blocks individually, and you might move different blocks of a file to different parts and like fragment the file. But that's not what we're doing with part 2. So there's a much better approach to part 2, where you just keep track of the position of the file and the length of each file. And then similarly for the free spaces, you have the position of each free space and the length of each free space. So I did that in part 2 here, not part 2 old. So you still have to read the input, and then you have to translate that input into those 4 arrays. So we have file, position, and length, and then the free space position and length. And you have like an odd number of inputs, so the number of files is usually 1 more than the number of free spaces, at least for like all of the example inputs that I saw. So you have to translate that input and like set up your file positions and lengths appropriately. The lengths, they only give you the lengths, and then the positions are implicit depending on the ordering. So this sets up those things. And then once you have those parsed and translated from the input, the rest of the problem is pretty easy. You're going to start filling up free spaces at the leftmost free space. So that's 0. And then you just loop through the files in descending order. And eventually you might be able to skip over some of the free spaces, which now have a length of 0. So I never really get rid of a free space. I just decrement its length, and eventually it will probably have its length decremented all the way to 0. So when that happens, you can skip over those and update this leftmost free space index. And then you start checking for free spaces that are big enough to accommodate the file. And you still have to have a guard against moving the file to the right. So you only want to look at moves that are moving a file to the left, not the right. So if you get this, you break. And then if the free space is big enough, if it's larger than or equal to the file size, then you can move it. So you don't really reorder the file in the array at all. You just update its position. It still has the same iFile index within that array. So you set that to the free space that you found, and then you update the lengths. The file length stays the same, but the free length gets decremented based on how much of it that you filled. Like, let's look at something visual. 9. So I think the example that they give does this. Like, you move the 9s into a free space that has a length of 3. So you don't remove the free space entirely. You just decrement this length from 3 to 1 free space. So that's what this does. You just decrement the free length based on which file you moved into it. And then you also have to shift it to the right, because this free space, instead of starting here, this free space now starts 2 to the right because the file had a length of 2. So that's what this does. It just increments the position. And that's it. That's all you need to do for part 2. And then calculating the checksum is a little bit different because you don't have all the blocks. You just have to like have another loop for positions within a block of the file. But that's the checksum part isn't really that hard. Yeah, so I spent like 2 hours on part 2 on the stream yesterday. And then I thought about it for not very long. I was like, it's going to be way easier if I do it this way. And it's a little bit shorter code. You have to translate the input, so that takes some work. It's still 100 lines. And if you look at part 2 old, this was like 150. So 144. So the code isn't that much shorter, but it's a lot easier to understand. You have a lot fewer nested loops, and you have fewer break statements and like break variables that I was using to emulate breaks. And a lot of this is just commented out print statements to confirm that I was moving things correctly. I think I got it on the first try. I implemented this in like 20 or 30 minutes, which was a lot faster than the original 2 hours that I spent on the old implementation. Yeah. I guess I alienated my viewer with that rant, so I only have one viewer. I guess there's no point rating anybody. I think did I commit? I did commit, and I pushed. I forgot about that. Let's confirm that. Yes, so that's what this commit was from yesterday. At a sane implementation for part 2. It was a lot easier that way. Let's confirm what we did today. There's my code. We've got directions. We've got a stack. This is the first day I needed a stack this year. I feel like I used a lot more stacks and queues last year for searching algorithms. I don't have recursion in Syntran. So whenever you have an algorithm like depth first search or breadth first search, which is usually recursive, I have to do it with a non-recursive implementation. And for that, I need a stack or sometimes a queue for other algorithms. Yep, that pushed. Yep, no viewers other than myself, so I'm not going to rate anybody. I think that's it for today. So thanks to everybody who tuned in. Really appreciate it. I will catch you next time. Bye.